Cool. I would just quickly recap what we talked about last week. So first we talk about the keyboard functions. So it should be basically the same as keyboard functions. Key pressed, key release, key typed. And you can do all sort of thing with these functions that's built in, so you don't need to rewrite it. So you can do something like, well, whenever a key is pressed. So this is sort of like draw. So draw is and something that will just be executed, keep being executed. And key press is the thing that will keep being code whenever a key is pressed. And then you can use key equal coded, key code left, right, up, down. So these are special ways to handle the arrow keys. But otherwise, if there's like space or A, B, C, D, whatever, then you can just use if key equal to those letters to do it. And we talk about else if, so that's just a easy way to sort of like fix this to save one line. And when your code gets longer, it's nice to keep it neat. You also have switch. It actually make it longer, but it actually has more, much easier to see an overview of what these options are and what happened with that. And recently I saw a Twitter like a Twitter post about the pinball game on Windows. You know that? Am I too old? The pinball on Windows. This thing. Have you ever seen this? Now I'm getting old, I guess. This thing? No? Okay. So anyway, this is the Windows pinball, I guess, like 10 or 20 years ago. But turns out, so someone dig into that code base, it's just a huge switch, syntax. So basically, the whole pinball game is also similar to that, whenever you press some key, and in each case, you have so many different keys, and some of the keys will control some of that, and you can restart, you can do all sort of thing, or even think about all the shortcuts that you have. So whenever a key is pressed and you want to get some shortcut, you just use case to get all the different keys and do something after that. So that's the nice thing about switch. You can sort of like it's a little bit different than if. Now you can only test whether this is equal to any of these, but it actually make it neater. And we talk about randomness. So we have, the typical uniform distribution, and this is the Gaussian distribution. It's the roughly shape. So everything will be equally likely. This will be more likely in the middle, less likely on the side. And this is the only thing you need to know about Gaussian distribution. Most likely, I couldn't remember the formula anyway, and no one can compute it likely. So 68, 95, 99.7, that's all you need to know for a Gaussian, most likely. And we talk about how you can sample uniformly in a circle. So this turned out to be very, very tricky. But anyway, give you the sense that, randomness is not something very easy to get, especially when you have a complex shape. So the naive, we started from rejection sampling. This is the most simple one. You just randomly get one point in the whole space, and then whenever it's not in that circle, then you just don't draw it. You just drop it. But that has the downside that do not always produce a point at each step. And we look at this naive approach where we use the polar coordinate. We sample a random angle and we sample a random radius to throw that point at. But the downside is that it's not uniformly sampled. It's denser near the center. And the last thing we talk about is inverse transform sampling. So magically, if you just add the square loop, and everything will turn out nicely when you sample the radius. So you want to sample the radius with a square root distribution. Cool. I don't think we finished us. Oh yeah, we stopped somewhere here. Yeah, so homework 2 will be paddle ball game. It will be due next Monday. Hopefully can get it done. If not, we can consider extending it. But shouldn't be too tricky. So it's similar to homework 1. Now just that your bottom wall will change size and it will move based on your mouse X and not mouse Y. So what I'm doing here is that, the middle of your mouse will be the middle of the pedal, and it will have a fixed size in the first question. So basically, these are the spec. Use the mouse to control the pedal bar. Just use mouse X and display that pedal. And you want to show game over when the pedal doesn't catch it. And all the other words, just like, homework 1. You feel free to use whatever colors or whatever shape if you like. Click the mouse to restart the game. So, you will game over if it doesn't catch it, and you just click the mouse. So you will want to use, void mouse clicked, and then you will restart the game by implementing that init function. So this will also put us into a different scenario where we are writing some functions. So this is the template sketch that I provide. So this is a little bit different from what you have in homework 1. So now this is the big thing that you want to write. So this is the initialization, initialize the game. And you see when it was called. So when you set up the whole thing, you create the canvas, you set the frame rate, blah, 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 and you will initialize the game. So now if you have initialize as a separated function, what you will do is that, in your setup part, you will initialize the game, but that will be the same when you click the mouse. So this turned out to be, the one of the benefit of function that you don't need to copy paste the same thing, because you will do it when you started the game in setup, but also when you click the mouse when the game is over to reset the whole thing. So you will write this initial function where you want to, put the paddle back to the middle of the screen, and then it will be gone right away because you have the mouse X. But you will shoot the ball toward a random direction upward. That's the whole thing about randomness that you want to do. So how do you shoot the ball to a random direction? There are so many different ways. So the first option is that, well, we just do speed X, speed Y, and then we just randomly shoot it. So I will get a random speed X, randomly get a speed Y. So now together they will just give me a random direction. But random 0 to 1, that will be just pointed this way. But think about it. I think I did it very bad. That's a typo. No one found it. Less messy. Okay. So this should be the way. So random -1 to 1. So you will potentially also get a negative speed X and negative speed Y. Then now you get the, a random direction toward this direction. So this is the first option. Pretty straightforward. Second option, now we use some square root. So this the question of this is that you cannot control the speed. The speed will not be the same. Say if you sample a big speed X, sample a B speed Y, then now the speed become much larger. And if you, for example, for this, if you get a very small speed X, very small speed Y, then you get something like this. So the downside of this is that you cannot choose, you cannot control the actual speed, because the combination between speed X and speed Y will get you something else. So the second option is that, well, now then let's compute y, given that we have the actual speed. So what we will do is that we will get speed x, and then assuming we know how long the speed is. So we know that, say, the speed is always equal to 5 or 10, whatever. Then we just compute this back by doing, square root 10 minus speed x squared to get the speed. So at least this will give us the same speed all the time. But what's the issue here? Does it actually get you a uniform speed? Does it? Hey, it's fine.
Essentially.
Oh, that's tough.
Yeah, it's like the only time I'm not professor there.
You know they are building the light rail between Central and North.
Really?
The plane.
What?
The plane. It's a plane. Nobody knows.
Oh.
But they're considering.
Like, so it'd be a high speed like train?
I don't know if it will be high speed, but it will be a train going from Central.
Cool.
Yeah, it would be cool. And I think they are planning the station just near so next to the pond on the other side. Who knows? But likely 4 years or 5 years, unless you are here. Still here. For some reason. Yeah, but anyway, yeah. Yeah, so what's the question of this? What's the problem of that? So you get a random x. It could be this, it could be this, it could be this. And then you get the corresponding y. Say this is the length you want. So bad at this. Let me try again. So imagine this is the speed that you want. And then you put the speed, you get a random x. So the larger you get, the smaller speed x you get, you will get you do this 10 minus x squared. You will get a different type of speed y. So I guess I just spoiled it. So the reason of this is that it's actually more likely to get this than this. Because you are sampling uniformly on the x-axis rather than the arc. So this is equally possible to get than this. So this short arc is of the same probability of this arc. So you actually get more chance to be in this range than in this tiny range. So that's the problem of the second one, that you don't actually get the uniform distribution of all the angle in 0 to 90 degree here. So if you want to get the uniform angle, then you will still want to use polar coordinate. So that's likely, hopefully, what you will be doing in homework 2, but it's fine if you want to use the other two. As long as you can get a random direction, then that's fine. So the last one is that, well, now we just get a theta, and we just apply cosine and sine theta to that. So you just randomly, so go from 0 to 2 pi to 2 pi, 0 to pi, and to 2 pi. You randomly get a number within this theta. So say randomly get this theta. And then you just use that setup to do speed times cosine theta, speed times sine theta. Then you will get the direction. Now the question in homework 2 is that the ball always go up, right? You don't want the ball to drop to the bottom. So when you initialize it, you only want it to be going from pi to 2 pi. So that's the key. So basically, this is the hint. So what you want to do is that you just randomly go from pi and 2 pi, and then you compute the speed x and y. That's how you can get the random direction that you need in initialization. And there's also, if you scroll down to the homework 2 page, this thing. This is also a little bit tricky. So one thing about the paddle ball game is that if you shoot it in the too low angle, it will take forever to reach the top and take forever to reach the bottom. So you will also want to sort of like constrain the angle of it. You likely notice this when you do a random direction, and then you will figure out that, well, I need to do something, unless otherwise it will never hit the top. So those are some of the details of homework 2. And the second part of homework 2 is just shrinking the paddle bar size to make it more fun. So whenever it hit it, this bar size will shrink. And it's up to you to define how fun it is. You can make it shrink much quicker, but anyway, it will stop at some place. And the second one is about stickiness. So stickiness is sometimes you play this paddle ball game, is that when you move the I think I should show it. Where is it? Oh, here. So I click it and then it will restart. So you will see that the paddle will be smaller when I hit it. And then now if I move, oops. So when I move the paddle, the velocity will be applied. It's so laggy. If I move, the velocity will be applied. So that's basically what you want to do. So you just need to compute the velocity of your paddle by doing mouse x minus p mouse x. So p mouse x is the immediate last position of your mouse. So if you do mouse x minus p mouse x, so p mouse x basically previous mouse x, this will sort of give you the velocity of your mouse or your pedal. So that you basically apply part of this, say 10%, 20%, whatever, to the ball's, x speed, so that you will apply some stickiness to the ball. So that's what you will be doing in the second part of the question. Questions? Cool. Have fun. I hope it's kind of obvious what we are trying to do here. It's just creating a fun paddle ball game, and you will get to experience function and all the things about mouse x, p mouse x, and controls. Mostly just mouse controls. Cool. Yeah, so p mouse x will be the value of mouse x in the previous frame. So we oftentimes use this to sort of like just compute the difference between them. Then you can get the velocity of how fast you are moving your mouse. Cool. So that's homework 2. Will be due next Monday. I think we got all the tools that we need to do it. Cool. Let's get into today's topic. Cool. So today we'll be talking about loops and recursion. Oops. And so for loops, you're likely very familiar with that because, as I said, the draw function is just a huge loop. It will just be executed again and again and again until you turn off the whole, terminate the whole program. Cool. So one of the most simple one is while loop. If you have taken any programming class or know how to program, this is likely too boring. But we would just go over some of the most basic part of it. So while it's just like if, but just that it's a loop. So while something is true, we just keep doing something. And so most of these, keywords, you just look at it in the most fundamental way. While condition do something, then that means that if it's true, then you will just repeat it again and again and again and again. Until the condition is false, then you will bypass that and then jump out of this while loop. So this is sort of like a block. And so if this condition is true all the time, then you might be, stuck in these things. And that's when we call that's an infinite loop, or it's non-terminated loop, which may be an issue for programming. So some examples. This is likely the simplest examples we can do with a loop. So you initialize x equals 0 while x less than 200. Then you just plot it, and then you add x to 20. So x plus equal 20, again, that's equivalent to x equal x plus 20. So that's the two things is equivalent. Okay, anyway, this is a while loop. You just keep, initially x is 0, and then you draw a circle x 0, 210. 0 is less than 200, so you will round this. And now you add 20 to x. Now x becomes 20. So now you check 20 is still smaller than 200, so that you draw it, and then you keep doing it all the way until the last time when x is 200. 200 is still, smaller or equal to 200, so you will draw it at the 200 point. But now x becomes 220. Then it no longer, satisfy this condition, so it will break the loop. So that's it. And there's also a friend of while loop. It's called do while loop. It's just a matter of ordering. So you do something while something is true, meaning that you do that thing first, and then you check for the condition. So it's slightly different from while loop, where you do something and then you check for the condition. If it's true, then we do that thing again and again until the day it's no longer happening. And there's one caveat where the syntax, you need to have a semicolon at the end. So the difference between while and do while loop is just the ordering of stuff. So while condition do something, meaning that we first check for the condition, and then we do something. If it's true, then we keep doing it until the day it's no longer true. And for do while loop is that when we do something, and then we check, and then we do something again, and we check until the day that it no longer hold, then we will break it. So there's a tiny difference between the execution ordering. So they are not always equivalent. In this case, they are equivalent, but in some of the case, they are not equivalent. So you can always sort of like turn the while loop into do while loop. You just move this while things at the end. So this is like, first I check x equal whether x is whole. this condition hold, then I do something. And in that case, is I do something, then I check. And so break is another way to just get out of the while loop in the middle. So while loop, you do have this condition. So you will do something, and then, whenever this condition is true, you can always do this. So this is actually equivalent to just putting that condition 2 into the while loop. So what you can do is that this thing is actually equivalent to while condition 2 and condition do something. So these two things are actually the same, because that, if you check for if and then you break. So these things will be the break syntax will be helpful whenever you have something else at the end. So, sometimes in for loop, while loop, whatever loop, if you want to break out of that existing loop, then you can use this break function. And it's a little bit complex because there are so many different options that you can use to get out of a loop. So there are break, there are return, there are exit, and there are no loop. So these 4 things all have sort of like similar behavior, just that they have some difference. So break is what I just said, that you will exit the current while for switch block. By block, we will talk about it later, but by block, it's basically meaning that these things. So, think about while loop as like a loop. So you will sort of like be trapped inside it until this condition no longer hold. Then you will get out of that trap. So break is sort of like jumping out of that right away. And so for return is that exit the current function. So sometimes if you write a while loop and then you have a return in that, you can actually just jump outside of the whole function. Not even beyond, beyond the block. And exit will stop the whole program. So whenever you code exit with the 2 parentheses, the whole program will just shut down. So that will turn off the whole program sketch. And no loop will disable loop in the draw function. So most of the time it will just stop, freeze the program. So these are some of the way that you could use these things. And they all have like slightly different behavior. So, we set up something in the draw function while condition do something, and then we can check for another condition, and we can use break, we can use return, we can use exit. But they will all have different effects. So for break, you will only exit the immediate block, the loop block. So now you will go out of this block. So you are no longer trapped in this while loop. Now you can go out of it and then do something. So this is the simplest way to get out of the while loop. So this is different from return. So what happened with this? Any idea? What's the difference between this and that? So as I said, return will terminate the function. Where's the function here? Any thoughts? No. What's the function? So the whole thing, that the while loop is not the function, that the function here is the draw function. So return will completely cut off the whole draw function. So once it detects this, if condition 2 is true, it will actually just jump out of this function. So the whole do something else things won't be even executed. So there's a difference between break and return. Break is to get rid of the current, the current block, current loopable block, and return will get out of the current function. And the function here is the draw function. So you will just return and get out of that. So do something else won't be executed. And even worse, if you are doing exit, then the whole program will be gone. So once you do exit, the whole, processing sketch will actually be closed. So there are, this is what we call about block. So this is the while block. This is the function block. This is the whole, whole program, the whole sketch block. So sometimes we also use scope. So this is the scope we are talking about. We are breaking outside of the scope, and this is the scope, and that is the largest scope. So so think about it like an onion, like in your programming sketch, there are so many different layers of that, and each of different things will move you toward a different layer. So that's the difference between break, return, exit, and we didn't show no loop here, but no loop is also very interesting because no loop will just stop, sort of like freeze the whole function, because the draw function won't be executed again and again. Cool. Likely not something you will experience right now, but good to know that they have different behavior. And so actually the no loop versus return thing will happen in your homework 2. So in homework 2, there's a tiny difference between return and no loop. So when we are doing this scan over, so as I said, whenever the game is over, we want to freeze the whole program. We don't want it to just completely get out of that thing. So what we will do is that you could potentially do a no loop or something else. But if you do the return, the whole program will be done. So you don't want to do return. Actually, no loop also have an issue about not saving the frames. Actually, just don't do return, because it will turn off the things. So when you are exploring homework 2, you will like this noted that it's scan over what you should do. So be careful about that. So if you do return, it would just redo this draw function again and again. But if you do no loop, it would just stop the whole thing. Oh, I was talking about return and no loop, not exit. So if you don't no loop, the whole draw function will be stopped. So in that case, when you are saving the GIF frames, you won't be able to get any frames between the game over things, because the whole draw function has been canceled, have been freezed. So you want to use return rather than no loop. You can play with it when you are working on homework 2, and you will get what I mean. Cool. And this is another version of while loop where you just do while true. So true is always true. So this thing will just do it again and again. So this is what we call infinite loop. Sometimes it can be handy, but it could also be very tricky, because you never know when it will stop or not. In some case, it might not if you didn't take care of the condition properly. Cool. Why are this here? I have no idea. Yeah, we just go over this. So now some exercise, I guess. Now we want to do a grid of circles. We want to get from 0, 0 to 200, 200, get a bunch of circles. So now what we need is like what we call a nested loops. So what you want to figure out is, how do you do it? So, we have this while x 200, x 210, x plus 20. And now, how can we get another while loop together? Any progress? what's going on? So this is what we have currently. So, you start x equals 0, and then you just keep adding x equal to x plus 20. And then whenever x is, smaller than 200, then you draw it. And if not, then you just exit. So what you want to do is now we also want y to be 0 all the way towards 200. So now we want to get another, variable, y equals 0. And so what we want to do is that, well, y is initially 0. And so now we want to have y here. Oops. So this will still just put it there. So now we want to make y equal to y plus 220. This will actually be fun. It will just keep moving, I guess. Oh, it's done. Oh. Cool. So we can actually get another while loop outside of that. So while y is smaller equal than 200, then we do this. So you can actually, do a nested loop where, the outside while loop is doing these things inside of the while loop. So this while loop is embedded inside this while loop. So this will go from, firstly y equal 0, then 0 is smaller than 200, then you will do this, then you will get the first line of circles. What's going on? Is there any issue? What did I did wrong? Did I do something wrong? Oh, yeah. Yeah. So we need to reset x equal to 120. Yeah, so what happened just is that x become 220 and the rest of y just don't get second. Okay, cool. Nice catch. Yeah. So this way you will get all of those. So you have to reset x since you are doing this while loop again and again. Cool. Cool. Yeah, so that's it. Oh, this just doing the x, y in a different ordering. So yeah, again, the caveat is that yeah, y equals 0. You have to reset it. Especially when you are done with this while loop, you want to reset it the next time you want to do that while loop again. Cool. So there are like 2 while loop nested, one nested in another. Oh, I put it there and then I forgot it. Anyway, so that is while loop. So now we will go into another commonly used loop, which is called for loop. So for loop is a little bit different from while loop in the case that for loop has this initialization. So here we have to set y equals 0, and then we do y plus equal 20, and then we check whether y is still less than 200. So this is just so commonly used because whenever you want to draw a bunch of stuff, you want to initialize and then increment and then check if it still holds. So because of this has been too frequently used, it actually has its own its own for loop for that. So this is a typical way how you do it. You flow x equals 0 and you check whether x is still less than 200. And at the end of this while loop, you will do x equal x plus 20. So because this is so common, so you can actually just turn that into just one single line. So for loop is that where we will start by defining x equals 0. And then we will keep checking for x if x is smaller than 200. And at the end of everything you computed here, x will be increment by 20. So that's the whole for loop is about. So it's actually equivalent to a while loop, just that it's much more neat. So initialization, condition check, and the update. So the update can be anything actually. So it doesn't need to be increment. It could also be decreasing. It could be time. It could be power law. It could be whatever, or you can even just do nothing. But the condition will stop working, most likely. So initialization, condition, update, that's the for loop syntax. So you initialize something, whatever that initialization is, and then the first thing you do is that, well, you check for the condition, because that's the while loop. The while loop is that you first check for condition and do something. And do while loop is the opposite. You do something and then you check for the condition. And so if it's true, you do something. If it's not true, you just don't do it. And the update will always be executed after the do something, the whole full loop block. At the end, you will update. That update could be anything. And then you will go back and check for condition. If it's true, you keep doing that, keep updating, keep increment your numbers until it's no longer out. So these are like some different ways of doing that for loop. So as we saw it, flow x equals 0, x less than 200, x equal x plus 20, then you can get all these circles. So that's the one way to do it, where we are, looping over the x position. So x now go from 0, 20, 40 all the way to 200 until this no longer hold. So the next one will be 220, but the condition doesn't hold, so that won't be executed. This is one way, but actually I tend to like this way better. So this is like you are looping over the circle index. So you are counting which circle you are doing, like which ball you are at. So you go from int I equals 0, I smaller than 10, I equal to I plus 1. So this is most likely the most common format of a for loop, where you just go from 0 to 10. So this thing will just go from 0 to 10. So you start from 0, and at the end, 1, 2, 3, 4, 5 until 10, and the next one 11 in the longer hold, so it won't be executed. So the trick is that you just time 20 to get the same effects. So now you are not doing X position because you know how to compute the position by the index of it. Then the for loop things will be easier, just that now you need to do some math. So these are just two different ways to do it. Okay, so that's the simplest for loop. Now let's do something fun. So we will do this. We want to draw regular polygons. So one thing about polygons is that we can do something like this. So we can do begin shape, and then in shape, close. So this is the custom shape that I talked about. And we want to do vertex, say 100, 100. 100, 200, 200, 200, and then 200, 100. So this will give us a square. So if you want to do triangle, so you can do, so what's going on here is that you have 100, 100, 100, 200, 200, 200, 200, 100. So, and then you close it so that it will be a, a square. So if we want to do regular polygons, say if we want to just do a triangle, then I don't know where we'll get this. Anyway, you just cut it down. So 100 to 100, 100, 200, 200, 200, and then you go back to the original one. So now, can you use a for loop to plot a regular polygon? So the hint is to use polar coordinate. This is likely a little bit challenging. We'll see. So let's just do this. What we want to do is to have a for loop where you have phi equals 0, phi less than 5, phi is plus. Cool. So let's try to finish this. What's going on? Can you do a regular pentagon? This is not regular pentagon, but anyway. Cool. So how can we do that? Any thought? Nope. Thought? Yeah.
But like in processing, but if the function is a predefined radius, then you can just take 360 degrees and divide it by the number of sides you want on the shape. And then just draw the vertex. So you just have a vertex within the for loop that
Yep.
iterates over.
Yeah, that's exactly what we were doing. So how do we do that? I guess for starting from index, it's likely too challenging. So we can sort of think about theta equal to 0. So we start from 0 and all the way toward when it's too big. So 2 pi. So remember that this 2 pi thing is actually a predefined global variable, which is very funky, but that's what it looked like. 2 pi. And so the tricky part is here. How many increment do you want? So if we want to do a polygon, each of that will be, the whole circle will be 2 pi. So basically for each step, you want to do 2 pi over 5. So what you would do here is that at the end of those, we would do 2 pi over 5.
Which part is it? Plus equal. Like you do theta plus equals 2 pi over 5?
Yeah. That's the same. You can do either. Just yeah. So these are equivalent. This will be easier to read. So once you've done with that, now what we want to get is assume we have a radius. Let's just get something here. Let's just don't do variable. We can refactor that later. So assume we have a radius of 100. What we want to do is, cosine theta. And sine theta. 100 times sine theta. Let's make it easier. Float x equal this. Float y. So now let's compute where the x and y position would be. See how this goes. Likely not done yet. Cool. Close enough. It's here. So everything is in the 0 position. So we want to add 200 to that. We want to offset to basically move it to the center of the things. Oh, nice. What's going on? Likely this 2 pi over 5 thing is not float. So we want to turn it into float. Is that the case?
If it is a float, you divide by 5,
It's just, yeah, I'm not quite sure. What's going on here? Let me see.
declare theta as an what for the instant to field theta very simplistic.
I think it's because of the 2 pi thing. Let's just do low. See what this thing is. Strings. Oh, it's a float. So it's not the issue. So what's the issue here? Somehow I'm very unlucky today. Oh, because I set theta as integer. That's the issue. Oh, okay, done. So I set theta to integer. So whenever you do this, theta will still be integer. That's the whole bug is about. Okay, so this is what we can get. So you can actually just change this to something else. 6, you will get the whatever 7, 8. Yep. You can even just make this thing as mouse X or something like that. Then you can just move around and it will change the number of that. And you can even just do 100. Then it will become more like a circle. 500. Then it will pretty much just like a circle because the resolution is not high enough. But anyway, that's what we can do. To get a regular pentagon, polygons. So one thing you will notice is that because of how processing started from 0 at the right, it will always like in this shape. If you want to turn it into the correct position, you want to start it with sort of like at the top. So there will be, anyway, we just turn everything for 90 degree. I think that should just work. No, it won't work. Anyway, you can fix it by turning it starting from the very top and then going through it. I think I have some example here. I won't waste more time on that. Cool. So that's basically what you can see. I hope that's the same. I just improvise. Cool. Pretty much the same. I'm using A versus theta. So A is angle, so that's also fine. So if you want to put it in the correct shape, you can actually just flip it. So what I'm doing here is that I just flip it upside down by minus half pi to turn it 90 degree so that everything will be on the upright position. So if I do half pi here.
Is there like value grading classes in processing? Or
Yeah. Class.
Yeah.
Yeah, definitely. We will get into that. And that's also why this thing could become a class or a function. It's up to you. Yeah. Yeah. I don't think we ever encountered class yet, but we will see later.
I'm just curious because I'm like, it reminds me a little of Arduino, and sometimes I remember like it's easier to just write everything sequentially.
Yeah. So it's it depends. So this thing you can also make it a function. You could make it a class. So whatever way you like, and everything in Java technically can be used in processing. So this thing, you can actually write Java code here. Sometimes it will show some errors, but most of the time you can do whatever Java can do.
Okay.
Yeah. And I think there's also a way you can save this into a Java file so that because this is sort of like built on top of Java. So there's a way you can actually just write Java inside it. And all the syntax is actually the same.
Yeah, I saw it.
Yeah. Yeah, they have the Python version is no longer maintained.
Oh.
So yeah, I don't recommend that. The most popular one is Java and the JavaScript one. JavaScript one is P5.js. That's also popular, but it's a little bit different syntax because you are using JavaScript.
Yeah.
Cool. Yeah. But that's also the interesting part of processing because it's connected to it's a high level programming language on top of either Java, even Python. I think you also have like an embedding language. I forgot, but yeah. Cool. I think I have some boring animations here. So anyway, you started at the top. So minus half pi. So originally you start from 0. Now minus half pi, you turn it into the top. So you start from the top position. And then you just go through it one at a time. And that's how you get it. So you can even do stars. So now for stars, it's well, now I'm doing the 5 stars, but now let's just go from, 1 at here, and then we divide it into 10. And then whenever the second one will be smaller radius, the next one will be larger radius. So we can do something pretty much similar to how you do a polygon. So that's basically just 2 polygons at the same time. The first one will be working on the outside vertex. And the other one will be the inside ones. And that with a smaller radius. So you have like radius 1, radius 2, and there will be an offset on the angle for half the angle. So, for this, you want to turn, 2 pi over 5. But now if you want to do a star, you want this angle. Now you want to turn halfway. So there will be, 2 pi over 10 rather than 2 pi over 5. And that's why we get here, angle divided by 2. So you can also get the stars. Questions? Nope. I guess it's easy to look at it. So in homework, just have fun. I think the only way to learn through all the caveats is just to write something. So as I said, there's these handy operators. So x equal to x plus 1 is the same as x plus equal 1, or you can do x plus plus. And that's also like C and C plus plus. So anyway, so x plus plus is the same as x minus x plus equal 1. So what you can do here, I don't have an example here. I have example here. So for integer I equals 0, I smaller or equal than 10, I equal I plus 1. That's the original form. You can do I plus equal 1, and the most iconic one is likely this I plus plus. So this is basically how you can look over an integer from 0 all the way to 10. And even more iconic, I guess it's not I equal 1 equals 0, I smaller than 10, I plus plus. So now I keep using the smaller and equal to 10. So this will actually give you 11 points. from 0 to 10, there will be 11 points. But if you use like just a smaller than rather than smaller than and equal to, then you will get exactly 10 points here. Anyway, these are some of the other things. So you can also do x minus minus, x minus equal 1, x equal to x minus 1. And the same for multiply and divide. Just that you don't get x times times and x divide in this case. So you can actually do reverse looping. It's a little bit interesting to look at the first time you encounter that. But think about for loop is just while loop. So now you can actually start from I equal 10 and you check whether I is larger than 0 and you just do I equal to I minus 1. So that's the way how you do reverse looping. So now you can go from 10, 9, 8, 7 all the way down to 0. So it's exactly, the same syntax. And so for loop is very, very versatile. Inside this, you can actually even just write a function. You can do stuff inside it. It's not just about, doing integer I equal 10. That's the simplest way to do it, but there's so many different ways you can use a for loop. It's just a different syntax for writing a while loop where you have initialization, you have condition check, and you have update. Cool. So one thing slightly relevant to for loop is this modulo. Is that how I pronounce it? Mod, for so many different ways of pronouncing it. So anyway, that's basically how you get the remainder. So the slash, you will get the quaternion. But if you do the percent sign, then you get the remainder. That's it. So this only happens in integer, because without integer, if you are doing float, which is just number with all the decimals, then you don't need this remainder thing. Anyway, this is nice to do something like this. So you can actually do even an odd detection. So this will be 0, 1, 2, 3, 4, 5, but now all the odd numbered one will be white and the even ones will be black. Because what we are doing is, we just do I% 2 equal to 0. This will basically mean that, if I divided by 2 and the remainder will be 0, that means that those are even numbers. And else will be odd numbers. So you can do something like this, and you can even do, something like this. Our RGB, now you just divide it by 3. So if the remainder will be 0, if the remainder will be 1, if the, remainder will be 2. So you can do RGB. So that's what I say. Percent sign is sort of like relevant to for loop, most of the case. Cool. Now jump back to the topics of infinite loops. Some people would write for loop in this way. For, and then there's just like 2 semicolons. This is the legit. This is legit. This is a valid syntax. So that basically means that do nothing, and do nothing for the for loop. So for loop, remember that the first one is initialization. So here the initialization is doing nothing. And then the condition check is do nothing. So nothing is checked. And the update is do nothing. So this is basically a for loop that just keep running again and again. And that's the same as the while true loop. They are exactly the same. They just don't do anything. Unless you have this if condition break. That's how you control the for loop. So you can sort of think about, potentially the draw function is sort of doing something like this. Of course, it's not, but the draw function in processing, you can imagine that it's just an infinite function. Oh, want an M card? Cool. So that's infinite loops. So, sometimes infinite loop can actually be useful, even though I typically recommend against that. So especially when you have so many different complex conditions and, some of these need to be computed, then in that case, these infinite loops could be useful. Cool. I think we're mostly done for the technical part. Now we can also do something like this. I think I will just skip this. So you can pretty much similar to how you do the while loop. You can also do nested for loops, but now you can see that it's much neater, and you won't forget to reinitialize the integer just like that 30 minutes ago. So for loop does have that initialization thing built in, so that it's much easier to handle all the initialization and updates. And you can also do these, half grid of circles. So this is fun, and oftentimes I don't really actually dig into that. So there are so many different versions. So this is how you get this. So, I equals 0, I less than 20, I plus plus, j equals 0, j smaller than 20, j plus plus. How do you get all of these? So you can actually use the outer I inside this for loop check. So we can get a sense of what that means. So in this case, we are doing I equals 0, I smaller than 20, I plus plus. So this is exactly the same. But the second one, so j is for y. So now for y, we go from y equals 0 to y equal I. So what does that mean? So, we start from x equal I. So imagine that at some point now we have x equal I. Now, instead of going from 0 all the way to 20, we just go toward 0 to I. So we only got, y equals 0 to y equal I. And then the same for here. Y is equal 0 to y equals, say, 18, 19, 20, so that you can get that half upper right part of the circles. So you can always, compute the different index in your for loop, especially in nested for loop. So sometimes it can become handy, especially when you are drawing these, triangles shapes. And the bottom part, now you do I to 20. So you go from y equal I to y equal 20. So you don't plot the first several y. And the other two, it's a little bit more tricky. So now you are doing the other way. So you go from y equals 0 to y equal 20 minus I. So this point will be 20 minus I. So y equals 0, then it's 20. Y equal 20 becomes 0. So you just need to do some computation. But technically, you can go over those. So this will be 20 minus I all the way to 20. So that basically, you can actually get all these four things just by computing the indexing. Questions on this? To be honest, I typically just randomly try one of that and just run and see whether I get it, and then I fix it rather than sit down and think about it. But anyway, these are the four options that you can do to get the four different half triangles, half squares. And one thing we also need to talk about in loop, especially in this block things, is about variable scope. So I talked a little bit about it in function, and the return versus exit versus break. So that's the variable loop. So variable scope. So variable scope is important. It's a bit tricky to understand, but over the time, whenever you meet some bugs, you will see what I meant. So what's going on here is that initially you initialize an I equal 1 variable. So this variable will be here. And then in your draw function, somehow you mess up and then you reinitialize an I here. So the variable scope is that, the newest created one will be used. So in this I, it will be refer. So you define a new local variable. So this I will refer to the most recent defined one, the local variable one, not the most recent defined, the closest scoped one that you have. And after the for loop, I will be 20. So because you go from I equal 1 all the way to 20. So at the end, I should be 20. But now if you look at the bottom code here, circle I times 20, 150. This I should be 20, but it is not that. The I is now becoming just 1. So this line is for this ball because it has a larger radius. So what happened here is that, once this whole block is done, this local variable is actually being, what's that word? It's not terminated. It's just like, we would call it like garbage recycling or garbage management. So this I is just being destroyed. I guess destroy is a better word. So this I is destroyed. So no one's know this I. This I only survived in this block. So once you are going to this point, now this local variable is gone because that block is already done. It's being destroyed. So it will refer to the last I, the most the closest I that you know. So that will refer to the original global I here. So this is just trying to tell you a little bit about the whole variable scope thing that's going on. So you always need to be careful about where your variable is defined. And I guess the top tip is just to avoid using the same name in different place of your code. But sometimes this will become tricky, especially when you're copy pasting or you import someone else's code, and inevitably you will likely have some I, J, K, things like that. It could be used again and again. But anyway, variable scope, over the time you get to experience it. So for for loop, everything defined here will only stay alive within this region. And so imagine the case where we get rid of this line and then we still run the code. It will throw the bug here because now I couldn't find where I is because this I is destroyed. And if you didn't define the global variable, then it won't be able to find I. So that's variable scope. I actually have another slide. Okay, so this makes it even more complex. So now, the difference between this and this is that here we have the integer. We are declaring a new variable, but now we are not declaring a new variable. So now this I, you are not getting a new variable. So we are actually just grabbing this I here. So that's why, at the end, you see this ball move toward that. So that sort of also give you the sense what variable scope is. Now they are referring to the same I because we no longer have that scope thing. We are in the same scope. Cool. I guess that's it. We will leave recursion next time. So recursion is very cool, even though very tricky to get it done. But we will look into it. So you can also do something like this. Cool.